Okay, so welcome back to another video. Today's question / problem we want to solve for is actually coming from the 2023 Tokyo Institute of Technology. And one of the questions from there is asked the following. We want to find the integral part of the real number, the integral of 0 to 2023 of 2 divided by x plus e to the x. So that might be a first-time definition for anyone new to this. You're thinking integral part, there's the integral right there. No, that's just a joke. So that's not what it really means. The integral part is, in other words, the same thing as an integer part, which means that of a real number, it's basically taking the integer of what is beside the decimal separator on the left side. So basically, we have to find what this integer is closely related to what this real number is going to equal to. So with problems like this, we actually want to use that strategy of finding some sort of like lower bound and upper bound. And that being the case, we're going to be using some inequalities to solve for this, and then, using a minimum and a maximum to determine like what's our max between of our real number over here and find the minimum. So that's a general synopsis over there. So we can actually find some functions somewhat similar such that we can use that sort of comparison. So with that out of the way, as I give that definition, I think you can understand like what's the objective here. So with that, why don't we actually just jump right in? So in order to find our bound, so let me just call this x over here. So I just also want to preface that x is not sort of the variable we're actually trying to find that value equal to. This is just showing a depiction of like what we're trying to solve, like an understanding of what we're trying to really do here. So this is a bounded sort of problem such that our minimum and max is actually in a form of an integer. Meanwhile, this is in a form of a real number. It's in between there. So with that, so I have that it's going to be strictly less than our integral, our given number over here. So 0 to 2023 of 2 to divided by x plus e to the power x divided by x. And I also want to keep in mind that, I should have said this also in the beginning, that let's just say that suppose that we're actually not given some sort of, device / calculator, because obviously you can actually put this in and then you get the value of what that real number is, and then you could just determine that integral part / integer part of what that number is equal to. So with that restriction, so this is the way how we're going to tackle things over here. So we have a lower bound and then a upper bound. I'm just going to call this x plus 1. So it has to fall between these two integers over here. They're not specifically have to be such that we have to solve for a variable x. This is just a depiction that I just want to, illustrate. So with this in mind, we're going to make some observations that such that x is going to be strictly, or not strictly, less than or equal to, I should also put this a different letter now that I think about it, because we have x over here, so I'll just call this y. So let's say y and then y plus 1. Same discussion I just mentioned, and doesn't really change anything. It's just different, it's a placeholder, I'll put it that way. We'll note that 0 is going to be less than or equal to y, which is less than or equal to 2023. This actually implies that this is going to be such that 2 divided by x plus e to the power x, we can actually make the distinction to say that this is going to be less than or equal to 2 divided by e to the power x. So using this, we can actually integrate both sides of our same bounds over here, so that this implies the integral from 2023 of 2 to the power, or 2 divided by x plus e to the power x dx is going to be less than or equal to the integral from 0 to 2023 of 2 divided by e to the power x dx. This is actually a much easier antiderivative to solve for, and the definite integral is going to be easy such that we can actually just use the chain rule over here. Well, not chain rule, use substitution rather. That's the opposite way of saying it. But this is coming as straightforward that you say that this is going to be the same thing as equal to -2 times e to the negative x. Evaluate this from 0 to 2023. If I just plug in 0, so, well, let's just say first, if I plug in 2023, so that means I have, this is going to be -2 divided by e to the power 2023, and then subtract, so plug in 0 over here, so that means that's just going to be 1, then minus, so then that's a plus 2. So this is going to be -2 divided by e to the power 2023 plus 2. We can also, of course, create this bound to say that this is actually going to be strictly less than 2. So with this being the case, we see that this entire integral over here, 0 to 2023 of 2 divided by x plus e to the power x, we know that it's actually going to be strictly less than the value 2. So with that being the case, now we just have to show the opposite direction. So let's just show that it is larger than 1. So you probably can take a guess and say that the answer is equal to 1, which it is, spoiler alert. Well, let's actually show that, because it's not necessarily the case. It could be less than 0, it could be less than a negative number. It has to fall somewhere of some integer value. But in this case, judging from this assumption over here, we can say that we want to assume that, yes, it might be bigger than 1, but let's actually show that for the opposite direction. So in order to show this opposite direction, so now I'm actually just going to call this z, for example. We want to find a z such that z is going to be less than or equal to 2 divided by x plus e to the power x. So I want to make a note to say that the following, that e to the power x is greater than or equal to x plus 1. So with this being the case, that I can actually solve for this inequality to say that this is going to be, we can write this as e to the power x minus 1 is going to be greater than or equal to x. So with this being the case, I'm going to move up here. So now we can actually create yet another inequality using that same rational function over here. And also with that, we actually change our bounds because of the fact that when we plug in this back in, that it's under the denominator, since the larger the denominator is going to be resulting as a smaller number compared to when the denominator is smaller. So with that, then that means I have that 2 divided by x plus e to the power x is going to be greater than or equal to 2 divided by, so replace this x with e to the power x, minus 1, and then plus e to the power x, which of course that's the same thing as 2 divided by 2 times e to the power x subtract 1. So with this being the case, now let's actually integrate both sides. So now I have the integral of 0 to 2023 of 2 divided by x plus e to the power x dx is going to be greater than or equal to the integral from 0 to 2023 of 2 divided by 2ex subtract 1 and then dx. So just to keep in mind, this actually is a bit of a harder of a antiderivative to calculate. We don't need to worry about that. We just need to calculate this antiderivative, this definite integral over here. Looks a little challenging, but if we actually just do a little bit of some manipulation, that being the case specifically, that let's multiply e to the negative x to both our numerator and denominator. So that'll yield us with 2 times e to the negative x, and then on the bottom I have 2, and then subtract e to the negative x dx. So let's do a little u sub. Let u equals 2 minus e to the negative x. Then du is going to equal to just e to the negative x dx. What do you know? We got something that cancels. So now I have this bound. I'm not going to change the bounds for this one because I'm actually just going to substitute the letter back afterwards. So this is going to be just 2 e to the negative x dx is going to be du, and then this is going to be u du. So then this will yield us with 2 ln of, plug this back in, so 2 minus e to the negative x, and then plug in our bounds from 0 to 2023. As you can see, if I just plug in 0, so that means that's just going to be a 1. So 2 minus 1 is 1, ln of 1 is going to be, of course, 0. So now what's really left is that this is just going to equal to, so 2 ln of 2 minus, so 1 divided by e to the 2023. Then what I can do is I can actually move the 2 back inside, so that's a square, the exponent, and then I'll expand that notation out to get that this is the following. So the natural log of 4 minus, so expanding that out, so 4 divided by e to the 2023, and then add this to 1 divided by e to the power 46. Okay, so with that being the case, then this is what we have. And also we can actually make a little create this upper bound such that this is actually going to be bigger than the following number, ln of 4 minus 4 divided by e to the 2023. I should probably, you know what I'll do is that I'm running out of space, so let me actually just create this little bracket over here. Okay, and so some things to note is that we have that the following number, 4 divided by e to the 2023, is of course going to be strictly less than 1. And another thing is that we know that e is going to be in between 2 and 3, those 2 integers. So now to reiterate all this stuff together, so I have the integral from 0 to 2023 of 2 divided by 2ex minus 1 dx is then going to be equal to just the natural log of, the natural log of 4 minus 4 divided by e to the 2023, and then plus 1 divided by e to the 4046. And then, so we said that we create this bound such that it's going to be strictly greater than ln of 4 minus 4 divided by e to the 2023. But we can also create yet another bound to say that the following number, ln of 4 minus 1, is going to be bigger than that. So we can actually use this side. So ln of 3, so ln of 4 minus 1. So that's what we have. And so over here, I have ln of 3 back here, which I can also create that this, again, yet another bound saying that this is actually going to be greater than ln of e, which of course this is going to be equal to 1. So then to reestablish all this, so now I'm actually just going to write this over here. So therefore, to say that 1 is strictly less than the integral from 0 to 2023 of 2 divided by x plus e to the power x dx is of course going to be strictly greater than 2. So therefore we can conclude that the integer part slash integral, so let me actually rewrite this to say the integral part because that's what I have written, integral part is equal to 1. So therefore that is our final answer to our question given, the integer part slash integral part, whichever of those terminology you want to use, but I'll say integral part because that's actually what is written down here. Our integral part is actually going to equal 1. And as you can tell that if you were to actually plug this into the calculator, you'll get that I believe the expansion is going to be 1.6 something. So of course that integer part is going to be equal to 1, just like I have written, and just calculating all these bounds over here that we actually just established. So there you have it. So yeah, that's pretty cool if you ask me.